Yeah. So how many of you gone through the examples that we have studied in last class? These examples? I hope most of you have gone through these examples. Right, everyone? Okay. So question number one, I'll just discuss. If you have any doubt, please ask. Okay. Question number one, anyone had doubt in question number one? It was basic example of Hess law. Yes? Yes, everyone? Tell me. So question number one, I guess no one had doubt in question number one. Okay. Question number two, tell me. Question number two, any doubts? Just message me, everyone. If you had doubt, please message me. These are solved examples. Okay. I hope everyone understood the solved examples. Yes, everyone? Tell me. Solved examples were easy. So you got the concept, how to solve, how to apply the concept of Hess law as well as other enthalpies, right? If you have solved, then you would have understood the concept. Okay. If you have any doubt, please ask. I guess question number three, no one had doubt. Question number four, three, four, no doubts? Or have you not solved? See, you have to attempt first. Okay. This is thermochemistry. Concepts are quite easy, but you have to attempt. If you're not attempting, then you won't learn. That's the thing. Okay. So you have to solve first. So we had around 20 examples, which will cover all the concepts. Okay. That's why I told you to solve this, because it is simple as well as conceptual examples that you could have solved. Okay. Right. I guess most of you haven't solved, because that's why you're not asking. Okay. I'll leave it to you guys. We will just discuss 6.3 and 6.4. Okay. In class exercise 6.3 and 6.4. Because these are examples, you have to solve it. If you're not solving it, if you're not even solving examples, then obviously it will be difficult for you guys to understand the concept. I keep saying, okay, we have been studying thermodynamics for how many classes? Tell me, for how many classes? Anyone can tell me? We are studying thermodynamics from how many classes? Around 8 classes. Okay, around 8 to 9 classes. Today might be 9th class, I guess. Okay, today might be 9th class. 8th or 9th. So I expect you to at least solve around 80 to 90 problems in thermodynamics and thermochemistry till now. At least 10 to 15 problems per day should be solved. Okay, if you're not even solving these much problems, then obviously you will be having difficulty in understanding the concept. Okay. Now, Sneha and Meet, please check the attendance, because many students are not absent, not present. Okay. And from now onwards, everyone should have the fixed email ID. Okay. So you should have only one email ID. Okay. To join in the classroom, we will get the reports. Okay. So we'll discuss. So anyone had any doubt in the concept that we studied in last class? Tell me. We will revise also. But anyone have any doubts? Specific doubts? Tell me. We studied what is enthalpy and what is thermochemistry. So the concept that we have studied in 6.3, right, was the basics of enthalpy and internal energy. The relationship between enthalpy and internal energy, that was delta H is equal to delta U plus P delta V. Okay, That is your relationship between enthalpy and internal energy and work done. So basically we have studied what is enthalpy. Okay, so it is the energy, it is the total energy which is required to create a system and to move a system, right? Or move a particle in the system, right? So that's why it is sum of internal energy, because internal energy is required to create a system, right? Okay, and then when it moves, right? So there'll be change in pressure and volume. So because of that, there'll be another energy term, right? That's why we have studied that H is equal to U plus PV. Okay, so delta H is equal to delta U plus P delta V plus V delta P. But since most of the experiments, most of the reactions that we have, right, are in constant pressure. Okay, that's why this term delta P1 will be absent. Okay, so that's why we will just take care of this equation. Okay, now if we revise, if we remember first law of thermodynamics, so this equation is somewhat like Q. Okay, right? So delta H is equal to Q in isobaric process, delta H is equal to U plus P delta V, and delta H is equal to NCP delta T. So that's what we have studied about delta H. Right, everyone? Tell me. Right, everyone? Okay? Okay. So see, so basic, first, what is thermochemistry? So basically, it is the study of heat change, right? Study of heat change when a reaction is taken place. Okay, right? Now, the reaction can be of many types. The reaction can be of many types. Depending on that, the enthalpy, the name of enthalpy will change, right? For example, if something is formed, then it is enthalpy of formation. If something is converting from one phase to another phase, then it is enthalpy of phase transformation. If an atom is breaking down, right? If a molecule is breaking down into atoms, so it is enthalpy of atomization, right? If something is being combusted, it is enthalpy of combustion. In the same way, we have enthalpy of neutralization, resonance energy, right? Okay, so actually, Sanya, my voice is loud and clear. Okay, it is totally clear. It might be because of your internet issues, Sanya, because I'm hearing myself and my voice is very clear. Everyone, can you just message? Wait. I guess you guys are messaging too. Wait. Okay. Message to host now. Current host. Okay. Current host. Message to current host. Because the mobile I was host. Okay. Right. Sanya, my voice is clear, but still I'll repeat. Okay, so I just said that we have different type of enthalpy depending on reaction, So when we talk about enthalpy of formation or anything, it is net change in enthalpy, which is enthalpy of product minus enthalpy of reactant. Okay, right? That is your standard enthalpy of reaction. Okay, me, just message me on WhatsApp. Okay, now apart from that, we have bond enthalpy. So bond enthalpy as calculated, we will use Hess law, right? Now, since we are using Hess law, the net sum of overall reaction, okay, net sum of overall reaction would be product minus reactant or reactant minus product. Tell me, for bond enthalpy, will it be product minus reactant, enthalpy of product minus enthalpy of reactant, or enthalpy of reactant minus enthalpy of product? Tell me. Yes, it is reactant minus product. That's what we have studied in last class, right? Because this enthalpy, bond enthalpy, is calculated using Hess law, right? We will break down each and every component and then we will add it, right? Okay, right? That's what you have to remember. Okay, and we know that if you talk about the energy exchange, you have to be very intuitive. For example, if you're breaking a bond, obviously you are supplying energy because you are breaking a bond. Okay, but if you're forming a bond, then the energy is released, right? So obviously the energy in breaking bond is always negative of energy which is released to make a bond. Okay, right? Okay. Now the standard reaction enthalpy, as I said, it is product minus reactant. Okay, product minus reactant. But when you talk about bond enthalpies, right, it is reactant minus product. Okay, right? Then we studied what was Hess law. So Hess law said that if we have multiple reactions, and if we have to obtain other reaction, okay, by adjusting those multiple reactions, then the net enthalpy of reaction would be sum or difference of individual reactions. Okay, so example, just see this example, right? See this example, we have C3H6 plus H2 gives C3H8, right? Then C3H8 plus 5O2 gives this, and then H2O gives this. Now, we have to find the enthalpy of this reaction. Okay, enthalpy of this reaction. So when you talk about enthalpy of this reaction, just see the reactant. How you have to understand then which reaction you need to add, which reaction you need to subtract, and what to multiply. Okay, so see, C3H6 is your reactant. So this is your reactant. C3H6 is reactant. So you have to add 1 plus. Now 9 by 2 O2. 9 by 2 O2. Okay. So this is 5 O2 minus half O2. Right. So I can say that, and C3H8 is not here, right? So it will be 1 plus 2. Okay, because if you add 1 plus 2, C3H8 will be cancelled, right? Now, if you're adding 2, we will have 5O2, but we have here 9O2, right? Okay, now this half O2 is in product side. Makes sense, right? If you add third one, this is in product side. So this will go to reactant side, then will be minus half O2. So 5 minus half O2 will be 9 by 2 O2. So if you add these three, right, this will get cancelled. Okay, H2O will get cancelled. Okay, H2 and H2 will get cancelled. So we are left with now, since we have 4 H2O here and 1 H2O here, so we are left with 3 H2O and 3 CO2. So this is your product. Okay, so in this case you just have to add these three. So it is just like solving linear equations. Okay, right? So if you add these three, you will get your net enthalpy of reaction. Okay, then we studied Born-Haber cycle. We studied how NaCl is converted from its natural state, right? So we had Na solid, Cl, half Cl2 gas. Now Na is converted into gases. Then it is donating 1 electron, which is ionization energy. Okay, right? So see this. This is your steps. So first is this NaCl, Na solid plus half Cl2 gives NaCl. This is your first, right? Direct. Now Na plus Cl gas. It should be Cl minus, by the way. Okay, this is okay. Cl take it because it is one step is gone. So Na plus and Cl. So Cl will gain 1 electron. So it will be Na plus Cl minus. So it is your delta lattice energy. So this is your Born-Haber cycle. I hope all of you remember Born-Haber cycle. We have explained, right? Okay, it is basically your 5 reactions. So see, it is your 5 reaction. First reaction, second reaction, third reaction, fourth reaction, fifth reaction. Got it, everyone? Right? We have discussed all these 5 reactions in last class. Okay? Okay. So this was it. This was for 6.3. Okay. So how many of you solved illustration? Tell me. If you haven't, please solve this question number 1. Tell me. Everyone, if you haven't solved it, please solve question number 1. Okay. Please solve question number 1. You have to solve each and every illustration. Okay. So the question number 1. See question number 1, everyone. Average molar heat capacity of ice and water is given, right? And enthalpy of fusion is given. The amount of heat required to raise the temperature of 10 gram of water from minus 10 degrees centigrade to 10 degrees centigrade, right? So this is your net change in heat energy, right? So we know that what is the formula of delta H? It is C delta T, yes or no? And average molar heat capacity is given, okay? Right? So just think about this. It is very easy. Tell me, everyone. Everyone, please solve and tell me what will be the answer. Okay. Just try to solve this. Everyone, try to solve this. Tell me what would be the answer. Okay. Right? Yes, there'll be 3 steps. So first we have ice. See, first we have ice at minus 10 degrees centigrade. Okay. Then this ice will reach up to ice at 0 degree centigrade. Okay, then this ice will converge into water at 0 degree centigrade. Then this water will converge into water at 10 degree centigrade, right? This is your first change of energy, second change of energy, third change of energy. Now this is delta H, right? And this is your delta H, but this is due to latent heat. Latent heat. Okay, got it, right? Latent heat of fusion. Okay, right, everyone? Okay, everyone. So for this first step, we know that for this first step, delta H or delta H total will be delta H1 plus delta H2 plus delta H3. Okay, so it will be C delta T1, right? C1 delta T1 plus, now this is, tell me, L, just L, because NL actually, or it is NC delta T. So you have to calculate number of moles of water. L is your enthalpy of fusion, right? Or latent of fusion, plus NC2 delta T2. Okay, that's what you have to do, right, everyone? I hope all of you understood this. So let's see. See, that's what it has been done, right? Okay, so the answer is around D. Okay, check, everyone. Yes, all of you got this answer. Tell me, all of you got this? Got the concept? Right, everyone? Okay, so I just want to let you know that we get the reports of everyone, that how much time you have spent during the class. Okay, so I thought it is not needed, but I have just checked the data. Most of you, right? Like around 10 students, they are very irregular. Okay, they do not attend whole class. Okay, they leave in between and they join late and all those things. So if you keep doing that and if you don't inform me, I'll be just sending the reports of your timings to your parents. Okay, or just I'll publish in the group. It's better. Okay, because I need not to say that how important it is to attend the class. We are recording class for your own good, right? So that you can revise, but it doesn't mean that you should leave the class. Okay, unless and until there's internet issues or there's some other issues, I won't recommend to missing the class. Okay. Okay, so question number one, it's easy. Now question number two, everyone. Question number two, it was easy. Tell me, everyone. Let's see question number two. Just think about question number two. Just think about this, right? Just think about this. You have to find what? The ratio of heat supplied to the system and the work done. You just have to use the formula, right? No, Aryan, check your answer. Check your answer, everyone. So what is the formula of dq, right? Tell me, what is the formula of dq? Yes, Aryan, that's correct answer now. Okay, tell me, what is the formula of dq? Because it is your isobaric process, right? So for isobaric process, I said that dq is equal to dh. Yes, so it is ncp dt. Yes or no? ncp dt, right, everyone? And we know that dw is what? dw is what? nr delta t, right? P delta v is equal to nr delta t. Okay, so you just have to use this formula, as simple as that. It was easy problem, right, everyone? I think it should be easy because cp is equal to 7 by 2r. Everything else will be cancelled. Okay, right? So it would be 7 by 2. Okay, everyone. Let's see question number 3. Let's see question number 3. By the way, we will have this Sunday we will have test of gaseous state. Okay, one more test of gaseous state. Okay, everyone, right? Be ready. This week we will have test of gaseous state, and next week we will have test of thermodynamics. Okay, I'm letting you know upfront, so please practice accordingly. So for chemistry, you will have 3 tests till next week. 3 tests. Okay. Try solving question number 4. See, in exam, you have to write these examples. Sorry, reactions. Okay. By understanding the energy given, you have to write these reactions by yourself. Now, because see, it is given the standard molar enthalpy of formation. So you should know what is the formation reaction. For example, CCl4. So if it is standard enthalpy of formation, means it is formed by its components. Okay. So when you talk about CCl4, the components of CCl4 are carbon and chlorine. So you have to react carbon, which is its natural form, which is graphite, and chlorine, which is its natural form. Okay. Same with H2O, same with CO2, same with HCl. So that is something you should know. Okay. You should know this. You can't say, sir, reaction nahi aata hai. It's basic common sense. If CCl4 is formed, what is its basic constituents? Tell me. It's obviously C and Cl2, right? You should know what is the elemental state of, or the standard state. Okay. Yes, Jasharan, you're close. Almost answer. Okay. Okay. Right. You just have to use Tesla here. You can find delta H. Right, everyone? What you have to find? You have to find delta U. So we know that delta U is equal to delta H, right? Minus, tell me. Now in this case, work done is not given. So which formula you have to use? Delta NG RT. Right, everyone? I hope all of you remember this. No, Karishma made some mistake. Srihari made some mistake. Pranjal, yes. Okay. First, calculate delta H. Everyone, first calculate delta H. What is delta H? Step by step, right? So according to Hess law, right? What is the reaction? This is the reaction, right? This is the reaction that you have to obtain. CCl4 plus 2H2O gives CO2 plus 4HCl, right? So how it can be obtained? Think about this. So if you add reaction C, just think about this. If you add reaction C plus 4 of reaction D minus reaction A minus 2 reaction B. That's the key, right? You should know which reaction to add, which reaction to subtract. Okay, right? Delta H was also wrong, Karishma. Okay, so if you calculate delta H would be minus 175 kilojoule per mole. If you calculate delta H will be minus 175 kilojoule per mole. Okay, right? See this? How to calculate? How to use Hess law? I hope all of you have understood the concept. Just see the reactant. CCl4, 2H2O. CCl4. So this is your reactant, right? This is your reactant. So it will be minus A. As simple as that. Minus A. Okay. What is your product? CO2 HCl, right? So CO2 HCl. So these two would be plus, right? And H2O is also a reactant. So this is also minus. So it would be C plus D. C plus D minus A minus B. Okay? Because you are inverting these two reactions. Now we have to find the coefficient. It is 2H2O. And here we have half H2O. So you have to multiply this by 4. Multiply D by 4. D by 4. Then you have CO2. CO2 is fine. 4HCl. But here we have, okay, this is also 4HCl because you have multiplied everything by 4. Okay? Right? Then this O2. See, if we are multiplying this by 4H2O, so we will get 4H2. Okay, 4H2. So you have to multiply this by 2, right? H2O, this H2, and this H2 will be removed because we don't have H2 over here, right? So 2B, right? So this is your reaction. Okay, okay, everyone. You just have to add it using Hess law. I hope all of you understood the concept. Yes or no? Tell me, everyone. All of you understood the concept? How to apply Hess law? Just raise your hand. Okay, very good, everyone. See, I'm requesting again and again, right? When you will practice, then only you will learn the concepts. Doesn't matter how easy it is. Khushi, you were absent yesterday. What was the reason? Tell me. Please don't be absent. Okay, otherwise you will miss the concepts. Have you watched the video? If anyone miss any concept, please message me. Okay, and please watch the videos. Okay, okay, Vishay. So pre-reading exercise. Let's see. Let's see. First one, enthalpy is dash function which can be related to internal energy as. This is easy, right? First one is easy. We have already done this. I hope pre-reading we have already done, right? Okay. Reading was easy. Let's solve in-class exercise. Question 1 and 2. Okay. Okay, Karishma, I'll try to find. Okay. I'll try to find and I'll upload. Okay. Before test, we will have one class of states of matter. We will discuss previous year of state of matter. Okay. Next week is doubt solving and discussion only. Okay. Next week we will have just doubt solving and discussions. One class I'll be giving for states of matter and one class I'll be giving for thermodynamics. Okay, question 1 and 2. Okay, Pranjal, 9, 11 and 12. 1 and 2, anyone have any doubt? I guess no one would have doubt in question 1 and 2, right everyone? Okay, 3 to 6, tell me. Question number 3 to 6. Okay, I'll just make one separate group for chemistry as for maths. Okay, I would encourage you all to please ask your doubts in groups. Okay, because see, I'll be very frank. It would be impossible for me to solve each and every doubts, and I generally don't solve doubts on WhatsApp group. Okay, but suppose, right? Suppose Sneha asks a doubt, and Anisha can solve it, or Aryan asks a doubt, and Ovas or Srihari can solve it, or Abhiram asks a doubt, and Aryan can solve it. So it's a mutual cooperation. So in that case, I will be discussing only those doubts who cannot be solved by anyone, right? It will be beneficial for everyone. Okay, so I'll just create a group of chemistry as in maths, and please, I would encourage whatever doubts you have, or if you get any good concept, post in the group. Okay, because you have to help each other. Not see, one student cannot solve all the books. That's a basic concept, right? Someone can solve one book, someone can solve another book. You have to collaborate with yourself. Okay, among yourself. Okay, 3 to 6, 5 and 6. Let's see. Okay, so 5 is easy, right? We know that delta H is equal to delta U, right? This is when delta N is 0. We remember this, everyone. I just discussed this. Delta H is equal to delta U plus delta NGRT, right? Please at least think about a problem before asking. Okay, so delta Ng is 0, right? Delta Ng is 0, then delta H is equal to delta U. Just think in which reaction delta N is 0. Tell me. Only doubts need to be asked. As simple as that. No one should spam with any other information, any other random things. Okay, doubts should be asked, and not even you have to attempt first. It's not that you have a doubt and ask, right? You have to attempt first. Okay, so it's easy. Yes, everyone, very good. Next, we have 6. Now tell me, in this case, same delta Ng, same concept of question number 5, same concept as question number 5. So what is delta Ng? It is 2 minus 4. So minus 2. So answer is B. Yes, everyone, very good. So 4 to 6 was easy. 7 to 10. So question number 9. Okay. So many of you have asked question number 9. Right, everyone? Question number 9. Okay. So let's see question number 9. How many of you solved question number 9? Tell me. In class, question number 9. Anyone have doubt? In class, question number 9. Okay. So let's see. Calculate delta H of a reaction. Just think about this. Calculate delta H of a reaction. Okay. Now reaction is this, and the standard heat of formation of H2O, this is given. So first of all, write down the reaction. Write down all the reactions. That's what I told you. Okay. So first reaction, heat of formation of H2O. It was H2 plus half O2. Half O2 gives H2O. Step by step. Delta H is given. What is delta H? Minus 57.8. Okay. Then CO2. So CO2 is C plus O2 gives CO2. And in this case, this is delta H1, delta H2, which is minus 94.5. 0.05. Okay. Okay. And third, C6H6. So C6H6 is C6C plus 3H2 gives C6H6, right? And in this case, delta H is equal to 19.8, right? Right, everyone? And overall reaction is C6H6 plus 15 by 2O2 15 by 2O2 gives 6CO2 plus 3H2O. So you have to think, this is your reactant, this is your reactant, should be minus, right? Right? So this is step A, step B, step C. So step C is minus, minus, right? Step C is minus. Okay? Then O2. So you have to add these two, right? So A plus B minus C. Okay? Now you have to adjust the, what you have to adjust? Coefficients. Now do you think that you have to add or subtract something? Tell me. Do you need to multiply any reaction with any constant? Tell me, yes or no? Or you will get it. You have to multiply this B, right, with 6. Yes or no? Because we have 6C. So you have to multiply B with 6, right? Okay? Right, everyone? And you have to multiply A with 3 because we have 3H2 here. Okay? So it will be 3A plus 6B minus C. Right, everyone? Tell me. Everyone got this? Yes? Right? Can you solve now? Tell me. Can you solve now? Okay, everyone? Right? So 6 into minus 94.05 plus 3 into minus 57.8 minus 19.8. Okay? Okay, everyone? Okay? Got it? Right? This is method 1. Method 1. Right? Now method 2. Why I taught you method 1? Because it is a basic method. Basic method. But since heat of formation is given, you delta H reaction is equal to summation of delta H formation of product minus summation of delta H formation of reactant. Right? Because delta H formation is given. Okay, so you can just use this formula also. So product we have 6 into CO2, 6 into CO2, right? Delta H of CO2 plus 3 into delta H of H2O minus delta H of C6H6 because O2 is your elemental state, free state. Okay, now this would seems quite easy, right, everyone? This would seems quite easy. But why I told you the method 1? Because method 1 can be applied, okay, for any reaction. You don't have to worry about bond enthalpy or anything because this is your basic method, right? But this one is only used when you have heat of formation. Okay, everyone? Now, since we had beta formation here, you can use product mass reactant. Okay, everyone? Okay, got it. Question number 9 done. Now 10 to 12. 10 to 12. Any doubts? Question number 10 to 12. 10 to 12, anyone? Question number 10 to 12. 10 to 12. Tell me. Question number 10 to 12. 10, 11. Okay. So let's see question number 10 first. Right? Now an athlete is given 100 gram of glucose. So you know the formula of glucose? Tell me. Right? Okay. Doesn't matter. Now 100 gram of glucose is equivalent to this kilojoule, right? So 100 gram, unitary method. Let's think. Give you 1560 kilojoule, right? He utilizes 50% of this gained energy, right? He utilizes 50% of this, okay, in the event. In order to avoid storage of energy in the body, what should be the weight of water that he would need to perspire, right? Now, this question seems difficult or easy. Just think about this. This question seems difficult or easy. It's actually quite easy, very easy. Just think about this, right? Just think about this. Total energy, 1560. Now 50% of this gained energy, right? So what's the 50% of 1560? 780, 780 kilojoule. Yes or no? 780 kilojoules. So this amount of energy he needs to require, right? Or he needs to perspire, right? So what is perspiration? It is conversion of water into vapor, right? That's it. Yes or no? Tell me. Yes or no? Right? Water to vapor. That's your perspiration. So we know that, right? ml is equal to 780. As simple as that. As simple as that. ml is equal to 780. Now since it is in mole, so I can just say NL or N delta H. N delta H vaporization is equal to 780. Yes or no? Yes or no? Right? Now what is this N? What is the number of moles? Okay, everyone. So you have to find this N only. है ना? You have to find this N. So first of all, let's see N is equal to 780 by 45. Yes or no? Tell me. Yes or no? Right, everyone? So this is your number of moles, and weight is number of moles into molecular weight, which is 18. So this should be your weight, right? Weight. Got it, everyone? Tell me. Got it? Not tell me. Was this a difficult problem? Just think about it. What is, like, is this a difficult problem? Tell me, everyone. No, it was yes, right? So you have to think about this. Okay. So there's a psychological effect if we don't see any formula. Okay, so you have to understand the problem. Now question number 11, 12, anyone doubt in question number 11 and 12? Tell me, everyone. 11 and 12. Mansi, Chulika, Anjali, everyone is getting. Vivek, Shreya, Suhas, Sai Smriti, Pritam, are you getting? You're attending class for the first time. Mansi, Koshi, everyone is getting now. Please be honest with yourself, right? Okay, Pradyuman is here. Pradyuman, you getting Pradyuman? Everyone's getting everything? Okay, question number 11 and 12. Anyone have any doubt? I guess question number 11, it would be easy, right? 11, any doubts? 11, doubt? Okay, some students have doubt. Let's see. So let's see. Equal volumes of two monoatomic gas A and B at same temperature and pressure mixed, right? The ratio of their specific heat Cp by Cv. See, when you talk about Cp by Cv, okay, just think about this. When you talk about Cp by Cv, we know that average formula of Cv average is equal to N1 Cv1 plus N2 Cv2 by N1 plus N2. Yes or no? Yes or no? Right? But since equal volume is given, right? So you don't have to worry about this equation at all. Okay, right? You don't have to worry about this equation at all. Yes, Abhiram, it is gamma because equal volume is given. But if instead of equal volumes, unequal volumes would have been given, you have to use this. Got it? Got it, everyone? That's why I told you this formula. Okay? Since equal volume is given, n will get common and it will be 2n. And the ratio also 2n. So it will be cancelled. So in that case, Cp by Cv this will be equal to gamma. But if unequal volume would have been given, it will not equal to be gamma. Gamma average would be different. Okay, everyone? Got this concept? Right? Okay. Question number 12. Question number 12. Tell me. Easy. Question number 12. Basic formula putting getting. Delta H is equal to okay, everyone. So delta H is given, right? Delta you have to find. This is the same problem. Okay, almost like same problem. Okay, everyone, right? One pressure is given, volume change is given. So calculate P delta V minus P delta V will be your work done. So delta H is equal to delta U plus P delta V. So delta U is equal to delta H minus P delta V. Okay, everyone. So you will answer. So you will get the answer of question number 12. Okay. Now question number 13, 14, 15. Okay. 13, 14, 15. Please try. Okay. It is for advance. Okay. So only those who are practicing for advance need to solve these, otherwise they can leave. Okay, remaining NEET students, you don't need to solve 13, 14, 15. Okay, right? We will discuss this later. Okay, okay, so let's come to our 6.4. Now 6.4, in 6.4, we have different type of enthalpies. Okay, so we see that we have enthalpy of combustion, enthalpy of neutralization, enthalpy of atomization, enthalpy of solvation. We have we have studied all these enthalpies, right, everyone? Right? Okay. So resonance energy, we have studied. What is resonance energy? Tell me, anyone? What is the relationship between resonance energy, actual energy, and theoretical energy? Tell me, what is the relationship? Actual is equal to theoretical minus resonance energy. Okay, okay, everyone. So illustration you guys might have solved. I hope that you have solved each and every illustration. You have to solve it. Okay, right? You have to solve this illustration. So see, you have to find for question number 3. Question number 3 was a good problem that you have to solve. First, they found delta H formation of overall reaction, right? This is your delta H theoretical, okay, delta H theoretical, then calculated it, delta H actual minus theoretical will give you resonance energy, right? Okay, okay. Now in class exercise 1 to 4, I guess 1 to 4 should be easy. One Pranjal, homework we will discuss tomorrow. Okay, homework we will discuss tomorrow because not many would have solved homework now. Okay, okay, Pranjal, we'll discuss in class exercise today so that everyone can solve homework till tomorrow. Everyone, please solve homework till tomorrow. Okay, tomorrow we'll complete this, and on Monday we will discuss TPP. Okay, everyone, right? Monday we'll discuss TPP. So till Monday, please solve all the TPPs. This Sunday, how many tests do you have? Tell me. This Sunday, how many tests do you have? Only chemistry test? Or there are maths and physics test also? Chem and maths. No physics test? It was yesterday. Okay. Fifth chapter test is taken, right? Fifth chapter test done. Okay. Okay then. Okay, Aviram. So question number till question number 5, I guess everyone could solve till question number 5, right? It was easy. Tell me anyone having doubts till question number 5? 1 to 5. Anyone having doubt? 1 to 5? No, it is easy. Okay, let me ask. Let me ask. Mansi, what is the answer of question number 4? Tell me. Mansi, answer of question number 4. Tell me. What is the answer of question number 4? Mansi, are you there? Mansi is not here, I guess. Mansi, yeah, what is the answer of question number 4, Mansi? That's what I'm asking. Just message me. You don't have to say, just message me. Okay? Everyone, please message your answer. Question number 4. Everyone should message. And we will play Kahoot today, by the way. We will play Kahoot today. Okay? It is C. Okay? It is C. Minus 57.32. You should remember this value. Okay? You should remember this value. Yesterday we have discussed it. Before that also we have discussed it. That heat of reaction of strong acid by strong base is just heat of reaction of H plus and OH minus, which is minus 57 kilojoule, right? Minus 57. See, you should not miss these small concepts. Okay? Question number 5. Tell me, what is the answer of question number 5? Which of them indicates the process of heat of neutralization? Sorry, heat of atomization. Yes, B, right? It is converting into atom. It is not heat of formation. Yes or no? There's a difference, right? Okay. Now 6 to 10. Tell me, 6 to 10. Any doubts? 6 to 10? Okay, 8, 9. Question 8 and 9. So let's see. Let's see. So when you talk about question number 8, what is given? A cylinder of gas supplied by Bharat Petroleum is assumed to contain 14 kg of butane. Okay, if normal family required. Now, isn't this very easy? Tell me, isn't this question very easy? You have to understand the problem first, right? What is number of moles of this petroleum gas? Tell me, what is the moles of weight of C4H8, C4H10, C4H10? The weight would be 58. Yes or no? Tell me, 58. Yes or no? Yes.
Yes.
Then number of moles will be 1400 by 58. Yes or no? This is your number of moles, right? Okay. Now, normal family require 20,000 kilojoule per day, and the amount of energy that C4H10 produce is 2058 per mole. So total mole is this. So total energy. It's a very simple problem. Total.
Okay, total energy supplied is equal to 2658
58 into number of moles 1400 by 58. Yes or no? Yes or no? Right? This is total energy. So number of days is equal to total energy by energy consumed per day, which is 20000. As simple as that. Got it? Now tell me, right? Tell me, was it easy or difficult? Tell me. Okay? Okay, everyone. Right? Okay, everyone. It was easy. Question number 9. Now just think about question number 9. Everyone, think about question number 9. If the enthalpy of solvation of 1 mole of H2SO4 in n mole of water is given by this equation. Now, don't you think that this is very easy problem? Tell me, don't you think that this is very easy problem? This reaction is already given, where n is moles of water. N is moles of water. Okay, 1 mole of H2SO4 and n mole of water. Now, in this case, 1 mole of H2SO4 is dissolved with 2 moles of H2O diluted with 90 ml of water. The total number of n would be how much? Tell me, what is total number of n? What is total number of n? Anyone? Tell me. So initial H initial because we have to calculate delta H na. So initial H.
So for initial delta H, we have to put 2 moles now. 6 into 2 by 2 plus 1.8. Okay, and final delta H after dilution. After
After dilution, it would be 6 into now 90 milliliter is how many moles? Tell me. 90 milliliter is 5 mole. Yes or no? Because 90 milliliter is equal to 90 gram, right? So 5 moles. So after dilution, it will be 5 plus 2, 7 moles. 7 by 7 plus 1.8. So you just have to subtract. Yes or no? Tell me. Yes or no? Got this concept? Okay, ठीक है. Okay, everyone. So question number 9 done. Next. 10, 11, 12. Tell me. 10, 11, 12. 10. Okay. Okay. So see question number 10. Everyone, just see question number 10. Right? Now, when you see question number 10, what is given? What you have to find? Okay, you have to find delta H for this reaction. Just think about this reaction. Okay, right? Now, don't you think that this can be solved using enthalpy bond?
Tell me, right? Okay. Now just think about this. Just think about this C6, sorry, CH3, COCH3. Okay,
Okay,
right?
right?
So
So
just think
just
about
think
this.
about this.
When we talk
When we
about
talk about
this
this
structure,
structure,
when we talk
when we
about
talk
this
about this
structure,
structure,
okay?
okay?
So in
So
this
in this
structure,
structure,
how many
how many
CC
CC
bonds, how
bonds,
many
how
CH
many
bonds?
CH bonds?
So I
So
can
I
say
can
that
say that
in order to
in order to
form
form
this
this
molecule,
molecule,
right?
right?
6
6
CH
CH
bond,
bond.
just think
Just
about
think
this.
about this. 6 CH bond. Yeah, got it. 6 CH bond plus 2 CC bond. Just write like this. 2 CC bond.
1 CO bond plus 1 CO bond. Yes or no? Tell me. Yes or no? Yes, very
Yes,
good.
very good. Okay. Now, when you talk about this, in this case, we have what? We have 3 CH bond plus 1 CC bond plus 1 C double bond O bond plus 1 C single bond O bond plus 1 OH bond. Okay, right everyone? Tell me, yes or no? Okay, okay, very good. So you can calculate the energy absorbed to form this, right, by adding these, and energy absorbed to form this by adding this. Yes or no? Yes or no? Right everyone? Okay. Okay. Now let's see. What about O2? Again, OO bond, CO2, CO bond, H2O, OH bond. Everything is given, right? Everything is given. So either you can break down each and every reaction, okay, and just use Hess law, or you can just calculate delta H of overall reaction is equal to total energy absorbed minus total energy released. Okay, okay, right? So better to calculate for every reaction and use Hess law. That would be the best. Okay, got it everyone? Tell me, got it? Okay, write down individual bond energy for all this compound and use Hess law. Okay, you can get the answer. Okay, everyone, got it? How to solve this now, right?
Now question number 11. Tell me everyone, 11 and 12, any doubts? 11 and 12? 11 should be easy. Question number 12, 11 should be easy, I guess. 12 should
12
also
should
be
also be
easy.
easy. 11 and 12 should be easy. At least give it a try. Okay. 12, question number 12. Try solving question number 12. Okay, everyone. Please be ready with Kahoot. Please be ready with Kahoot. Okay. We'll play Kahoot today. So in week, once we will play Kahoot. Which day? That is surprise. Okay.
The same
The
chapter
same
only?
chapter only.
This chapter
This
only.
chapter only.
Or should
Or
we
should we
solve
solve
states of
states
matter?
of matter?
Tell me.
Tell me.
States of
States
matter?
of matter?
Okay, let's
Okay,
solve
let's
states
solve
of matter,
states
I
of
guess.
matter, I guess.
Right?
Right?
Ready everyone?
Ready, everyone?
Okay.
Okay.
We have done
We have
this,
done
yeah?
this, sir.
We have done
We have
this?
done this.
Tell me.
Tell me.
All the
All the
three.
three.
Okay, sorry.
Okay, sorry.
Now,
we
we have done
have
only
done
one,
only
right?
one, right?
Ideal gas.
Ideal gas.
Yeah, screen
Yeah,
is shared
screen
now.
is shared now.
Have we done
Have we
this
done this
states of
states
matter?
of matter? Okay, yeah. Have we done this? Yeah, it's fine, it's fine. Got it. Right? No, right? Real gas we haven't solved now. Okay.
We will play this. Be ready. Ready everyone?
Ready, everyone? Okay. Ready. So you can see the code, pin code on the screen within few minutes. The code is 749 74927. 74927.
Everyone, please
Everyone,
join.
please join.
Those who will be absent here without informing will be marked absent, by the way.
Try from your laptop, because you can just log into kahoot.it on your web browser. If app is not working, you can just log into kahoot.it. You don't even have to log in. You just have to play the Sorry, just enter the pin code, okay? $27 players till now. $28. Everyone please join. Only 28 players till now. This is not an optional quiz, by the way. Okay. Who is this adorable oryx? Who is this adorable oryx? Message me. If you won't message me who is adorable oryx, you will be absent. Okay? Right? Okay. So 29 players, 31. Everyone fast. We will start the game now. Okay? The code will be shown at the bottom. Those who are joining late, the code will be showing at the bottom. Okay? The code will be shown at the bottom. You can join in midway, it's fine. Okay? Just see the problem and solve by yourself. Dominance of strong repulsive force among the molecules, right, of the gas. Okay? Right? Tell me. Depends on Z and indicated by Z is equal to 1, greater than 1 or less than 1. Only 10 answers till now. This question should not take more than 10 seconds. It should not take more than 10 seconds. It's a conceptual problem. Please answer. You have 2 seconds left. 1 second left. I'll skip it. Okay? 7 seconds, 6 seconds, 5, 4, 3, 2, 1. Okay? Let's see. 11th student made mistake by opting option A. Then 21 option B, 4 option C, and 6 option D. Obviously, repulsive force. What's the meaning of repulsive?
We have already studied that if repulsive force is there, then Z is greater than 1. And if attractive force is there, Z is less than 1. Right? You have to remember the concept. Let's see the scoreboard. I will skip it in 30 seconds. Right?
Right?
You won't be
You won't
having
be
80
having 80
seconds
seconds
till the timer
till
50.
50.
Okay?
Okay?
I'll skip
I'll skip in
30
30
seconds.
seconds.
Okay?
Okay?
You have 20
You have
seconds
20
left.
seconds left.
Everyone answer
Everyone answer
quickly.
quickly.
10
10
seconds
seconds
left.
left.
9
9
seconds.
seconds.
8
8
seconds.
seconds.
Everyone
Everyone
reply
reply
quickly.
quickly.
Everyone
Everyone
reply
reply
quickly.
quickly.
It will be
It will be
skipped.
skipped.
It's
It's
basic
basic
formula.
formula.
Okay, Nishita, it's fine. Don't
Don't
worry.
worry. Only 13 correct answer. Only 13 correct answer. At low pressure, we have studied, right? At low pressure, volume would be more. V would be greater than NB. So B will be ignored, right? Okay, let's see next. I will give you only 30 seconds from now. We don't have 80 seconds. We will just have 30 seconds. So read the question and answer properly. The term that corrects
You have only 30 seconds. Till the timer reach 50, that's it.
ten seconds. Everyone 10 seconds. Okay. So this is n squared a by v squared now. How come it is negative, right? These questions should take only 10 seconds. The temperature at which real gas obeys the ideal gas. See, only 10 seconds left. You have a habit of answering late. You won't be able to answer this. 4 seconds left. 3 seconds, 2 seconds, 1 seconds. Time's up. Only 26 answers. It is Boyle's temperature. It is basic definition. According to KTG, according to kinetic theory of gas, it's easy. Time's up. Only 15 answers. Very good. You have to be very fast. These questions should take 1 or 2 seconds. Just read the option correct. Most readily liquefied value for A. Now tell me, this is problem that we have done in classroom. Okay. How many times I have told you that value of A, if value of A is more, then it is attracted more and it can be liquefied easily, right? We solve this in module also. Okay. Which screen, Srihari? It is visible on Zoom. Okay. It is visible on Zoom, na? Everyone can see the screen, I guess, on Zoom. Try for next problem. Okay. The van der Waals constant B of gas is 4 pi into 10 power minus 4. Okay. How near can the center of two molecules approach each other? Then just go to kahoot.it. Only 7 correct answer. What you have to do here? Tell me. Message me. What you have to do here? What you have to do here? Tell me. It is approx anyways. Okay. B is equal to what? B is equal to, tell me, 4 into 4 by 3 pi r cube, right? You just have to use this. Okay, Aaron, we will check what is the correct answer, but this is what you have to solve. Okay. Okay, next. Only 3 students were correct. Only 3. Very good. Z is equal to what? Z is equal to what? V ideal by VDL by V ideal or V ideal by VDL? Tell me. Message. Only 3 students have answered correctly and only 13 students have answered. Very good. So this is how you are revising your chapter. Anyone? Aryan, tell me what you have to do here. Tell me, anyone? Z is equal to PV is equal to nRT. P is given. Volume you can find because density is given. R is given, T is given. Okay, Shrihari. No change. Second last problem. Highest critical temperature is shown by. Highest critical temperature is shown by. Tell me. Easy. This question will not take more than 30 seconds. I will stop at 60 seconds, by the way. I'll skip this question at 60 seconds. 10 seconds left. Two seconds. Only 9 correct answer. What is the formula for critical temperature? Tell me. What is the formula for critical temperature? What's the formula for critical temperature? This is very disappointing. Very, very disappointing. 80 by 27 RB. So if the value of A is more, critical temperature would be high. A depends on hydrogen bonding. Water vapor, right? And ammonia both can have hydrogen bonding, but water vapor will have stronger hydrogen bonding. Last question. Last question. Now see the scores, right? For every question, you get 1000 score. For every question, you get 1000 score. Okay. If helium is allowed to expand in vacuum, it liberates heat because 10 seconds left. Again, 10 seconds left. 5 seconds. Time's up. Okay. Let's see the podium. Aryan third position. Second Jasharan. Who is first? Pranjal. Okay, very good. Fourth is Ronak. Fifth is Soumya.